A very good morning, student. Today let me start the physics class from your 4th lesson, 12th standard physics. The topic is AC generator. What is meant by AC? What is the expansion of AC? Alternative current. Generator. What is the process of generator? Energy conversion device. Generator is an energy conversion device. So, let me start the introduction about the AC generator. AC generator or alternator is an energy conversion device. Please note it down, children. Energy conversion device. It converts mechanical energy used to rotate the coil or field magnet into electrical energy. So simply says mechanical energy is converted into electrical energy. So the AC generator, otherwise called as a alternator. Alternator produces a large scale electrical power for use in homes and industries. AC generator or its components are shown in this figure. These are the components which is used to operate the AC generator. First component name is stator. Second one is rotor. Third component is alternator. Fourth one is brush box. Then fifth one is slip rings. So these are all the component is very important to operate the AC generator. Then next, principle. What is the principle used in the AC generator? Alternators works on the principle of electromagnetic induction. So this point is very important for your objective type question also. Please note it down, children. Alternators works on the principle of electromagnetic induction. The relative motion between a conductor and a magnetic field changes the magnetic flux linked with the conductor, which in turn induces an EMF. So already we know the process of producing EMF whenever the magnetic flux linked with the conductor, which is produced the induced EMF from the Faraday's law concept. So the magnitude of the induced EMF is given by Faraday's law of electromagnetic induction and its direction by Fleming's right hand rule. Do you know the Fleming right hand rule? So stretch your right and 3 fingers mutually perpendicular to each other, thumb finger and forefinger or index finger and middle finger stretched in mutually perpendicular to each other. So thumb finger is represent the motion and the forefinger it is represent the field. Then middle finger is represent current. So here according to the Fleming right hand rule, based on this rule the AC generator is working. Now the construction is alternator consists of 2 major parts, namely stator and rotor. So please note it down. Alternators or AC generator consist of 2 major parts, namely stator and rotor. As their names suggest, stator is stationary while rotor rotates inside the stator. So stator is stationary while rotor rotates inside the stator. In any standard construction of commercial alternators, the armature winding is mounted on stator and the field magnet on rotor. Then the first part of the AC generator is stator. The stationary part which has armature winding mounted in it is called stator. So here this is the picture of stator armature wind inside the stator. Here, armatures are winding inside the stator. So it has two components, namely stator core and armature core. There are two cores. One is the stator core. This is the stator core. This is armature core. So two important components of the stator is namely stator core and armature winding. Stator core or armature core is made up of, please note it down, iron or steel alloy. Please note it down, children. Stator core or armature core is made up of iron or steel alloy. It is a hollow cylinder and is laminated to minimize eddy current losses. This is the hollow cylinder shape, which is covered or laminated by the sheet because we will reduce the eddy current. So this is the stator core. Armature core is made up of iron or steel alloy. It is a hollow cylinder and is laminated to minimize eddy current loss. The slots are cut on inner surface of the core to accommodate armature winding. Slot are cut on inner surface. So cut on inner surface. This is the cut on inner surface because of the core to accommodate armature winding. So armature winding is the coil wound on slots provided in the armature core. Then second part is rotor. What is meant by rotor? Rotor, it contains magnetic field windings. So this is the rotor part. Rotor contains magnetic field winding. The magnetic poles here, north pole and the south pole, are magnetized by DC source. Magnetized by DC source. The magnetic poles north and south are magnetized by DC source. The ends of field windings are connected to a pair of slip rings. This winding is connected to the slip rings attached to common shaft. This is the common shaft which rotor rotates. Slip rings rotate along with rotor. Here, slip rings rotate along with rotor. To maintain connection between DC source and field windings, two brushes, here this is the two brushes. Two brushes are used with continuously slide over the slip rings. Two pole rotor is shown in this figure. We will discuss the construction and working of two examples, namely single phase and three phase AC generator, in the following section. So the next topic is advantage of stationary armature rotating field armature. Advantages of stationary armature and rotating field armature. So alternators are generally high current and high voltage machine. So please note it down, children. Alternators are generally high current and high voltage machines. The stationary armature rotating field construction has many advantages. A few of them includes. So these four important points is the advantages of stationary armature. First advantage is the current is drawn directly from fixed terminals on the stator without the use of brush contacts. So current is drawn directly from the fixed terminal. This is the first advantage. Second advantage is the insulation of stationary armature winding is easier. So winding process is very easy. The insulation of stationary armature winding is easier. The third advantage is the number of sliding contacts slip rings is reduced. Moreover, the sliding contacts are used for low voltage DC source. So this is a very important point. Sliding contacts are used for low voltage DC source. Then last, fourth advantage is armature windings can be constructed more rigidly to prevent deformation due to any mechanical stress. So last uses very important uses. Armature windings can be constructed more rigidly. Rigidly means does not change the shape and size. More rigidly to prevent deformation due to any mechanical stress. So these 4 points are very important for your 2 mark as well as the objective type question. The next topic is single phase AC generator. Single phase AC generator. In a single phase AC generator, the armature conductors are connected in series so as to form a single circuit which generate a single phase alternating EMF, and hence it is called single phase alternator. So single phase alternator, it contains only one armature. Single armature conductors is connected to series as to form a single circuit. This is a single circuit. This armature, single armature is connected to the connectors are connected in series. Here this is the series pattern as to form a single circuit which generate the single phase alternating EMF, and hence it is called single phase generator. Single phase alternator. In the simplified version of AC generator, a single turn rectangular loop, this is the rectangular loop, the name is called PQRS. This is the rectangular shape of loop, PQRS, is mounted on the stator. Here this is mounted on the stator. The field winding is fixed inside the stator. Field winding is fixed inside the stator and it can be rotated about an axis. This is the axis. About an axis perpendicular to the plane of the paper. So the loop PQRS is stationary and is also perpendicular to the plane of the paper. Then when field winding are excited, magnetic field is produced around it. Here magnetic field produced around it. Let the field magnet be rotate in clockwise direction by some external means. This is the figure 4.28. Clearly indicate or shows the parts which is connected in this stator and armature and the circuit. Then assume that initial position of the field magnet horizontal. So assume that initial position of the field magnet horizontal. Field magnet here, this is the field magnet which is placed in the horizontal position. At that instant, the direction of the magnetic field perpendicular to the plane of the loop PQRS. This magnetic field is perpendicular to the rectangular loop PQRS. This is induced. The induced EMF is 0 because the phase of the rectangular loop as well as the magnetic field in the same direction. So that is why the angle is 0. So induced EMF is also 0. This is represented by origin O. So here this is represented by origin O because field and the surface of the rectangular loop acting in a same direction. That means omega t is equal to 0. So induced EMF value is also 0. Then second step. This represented by origin O in the graph drawn between induced EMF and time angle. When field magnet rotate through 90 degree, here when field magnet rotate towards to 90 degree. Here this magnetic field rotate towards to 90 degree. 90 degree means omega t is equal to pi by 2. This is the point A, which is indicate field magnet which is rotate towards to 90 degree. What happened? 90 degree magnetic field becomes parallel to the PQRS. Here magnetic field which is parallel to the PQRS. The induced EMF across PQ and RS would become maximum. So induced EMF is maximum at 90 degree position. That means point A indicated maximum induced EMF. Maximum induced EMF. So since they are connected in series, EMF are added up and the direction of total induced EMF is given by Fleming-Reuter rule. Very, very important point, children. Please note it. EMF are added up and the direction of total induced EMF is given by Fleming-Reuter rule. Care has to be taken while applying this rule. The thumb indicates the direction of the motion of the conductors with respect to the field. For clockwise rotating poles, the conductors appears to be rotating anti-clockwise. Hence, thumb should point to the left. The direction of the induced EMF is at right angles to the plane of the paper. For PQ is the inward and for RS it is outward. Here PQ is inward, then RS at the outward. Therefore, the current from along PQRS, the point A in the graph represent this maximum EMF. So this point is indicate the maximum EMF. For the rotation of 180 degree here, the magnetic field rotate along towards to 180 degree from the initial position to this position. The field is again perpendicular to here. The field is again perpendicular to the loop PQRS, and the induced EMF become again zero. Induced EMF at 180 degree of rotation is zero. This is represented by point P. The field magnet becomes again parallel to the PQRS in this 270 degree for 270 degree rotation of field magnet. This the induced EMF is maximum, but the direction is reversed. Thus the current flows along the S or QP. That means reverse direction. The current flows in the reverse direction S or QP. This is represented by the point C. On completions of 360 degree, the induced EMF become zero and is represented by the point D. From the graph, it is clearly that EMF induced in PQRS is alternating in nature. Therefore, when field magnet completes one rotation, this is the one rotation, induced EMF in PQRS finishes one cycle. Then next topic is polyphase. Polyphase means more than one armature or coil. Some AC generators may have more than one coil in the armature core, and each coil produces an alternating EMF. In these generators, more than one EMF is induced. Please note it down, children. In these generators, more than one EMF is produced, because this is the polyphase AC generator, more than one coil. So more than one EMF is produced. Thus they are called polyphase generator. If there are two alternating EMFs produced in a generator, it is called two-phase generator. If there are two alternating EMF produced in a generator, it is called two-phase generator. In some AC generators, there are three separate coils which would give three separate EMFs. Hence, they are called three-phase AC generator. Please note it down children. Very, very important point this is. In some AC generator, there are three separate coils which would give three separate EMFs. Hence, they are called three-phase AC generator. So, the next topic is three-phase AC generator. In this simplified construction of three-phase AC generator, the armature core has 6 slots. Here 6 slots. 1, 2, 3, 4, 5, 6. Totally 6 slots. Cut on its inner rim. Cut on its inner rim. Each slot is 60 degree away from one another. 6 armature conductors are mounted in these slots. The conductors 1 and 4, here 1 and 4 are joined in series to form coil number 1. The conductors 3 and 6 form coil number 2. While the conductors 5 and 2 forms coil number 3. So, these coils are rectangular in shape or 120 degree apart from one another. The initial position of the field magnet is horizontal and field direction is perpendicular to the plane of the coil number 1. As it is seen in single phase generator, when field is rotated from that position in clockwise direction, alternating EMF 1 in coil 1 begins a cycle from origin O. This is shown in the figure 4.31. Here, the coil number 1 start from 0. Then the coil number 2 start from 120 degree. Then the third coil which is start from 240 degree. So, 3 armatures are start from 3 different points. So, the corresponding cycle for alternating EMF 2, here EMF 2 in the conductor at point A, this is the point A, after field magnet has rotated through 120 degree. Therefore, the three-phase difference between 1 and 2, two-phase difference 1 and 2 is 120 degree. Similarly, EMF 3 in coil number 3 begin its cycle at point B after 240 degree rotation of field magnet from initial position. Thus, these EMFs produced in the three-phase AC generator have 120 degree phase difference between one another. So, this is a very, very important process. Three-phase AC generator in your 3-mark question also. Then, advantages of three-phase alternator. So, very important 2-mark question. Advantages of three-phase alternator. 2-mark as well as 3-mark question. Three-phase system has many advantages over single-phase system. Let us see a few of them. For a given dimension of the generator, three-phase machine produces higher power output than a single-phase machine. So, this is very, very important uses. Three-phase machine produces higher power output than a single-phase machine. Then the second point is, for the same capacity, three-phase alternator is smaller in size when compared to single-phase alternator. So, size is smaller. The third advantage is three-phase transmission system is cheaper. A relatively thinner wire is sufficient for transmission of three-phase power. So, this is the cheaper one. First point is produces higher power, high level power. Then second one is smaller in size. Third one is it is very cheaper. So, these are all the advantages for the three-phase alternator. This is very, very important point for your 2 marks, 3 marks as well as the objective type questions. Thank you very much, children. So, this important topics are So this is a very important topics. AC generator and advantage of stationary armature or rotating field armature, then single phase AC generator, then polyphase AC generator. The last one is three-phase AC generator, and the last topic is advantages of three-phase alternator. These are all the topics for your 5 mark, 3 mark as well as 2 mark question. Thank you very much, children.